Hey guys, and welcome to our lesson where we'll be breaking down borders. Well, if you think of brackets as being like borders or boundaries, which are keeping expressions in their place, if we could remove those brackets, then the terms within the brackets would be free to move around and interact with the terms outside the brackets. This is also known as expanding brackets. My name is Miss Danielson, and let's get started. I'm hoping you've seen my previous lesson called Expanding Brackets. I'm linking it down in the description box below, but that's where we were expanding brackets where there was just a single term outside the bracket. Today we're expanding two sets of brackets, so that's a little bit more advanced, but you should definitely know the basics first. Brackets are used in calculations to maintain the order of operations. They tell us to perform the operation inside the bracket first, but sometimes we can't. If we've got x plus 3 inside a bracket, we can't perform that calculation because x and 3 are not like terms, so they can't be grouped, nor can x minus 5. So what do we do then? We have to remember that a value directly in front of a variable, like 2, right in front of an a, means multiply 2 times a. So does a term directly in front of a set of brackets. Like, for example, 4, directly in front of the bracket, x plus 3. Now, this example is very similar to the examples we saw in our previous lesson on expanding brackets. When you've got a term directly in front of a set of brackets and you can't work out the result of what's inside the brackets first, you have to remember that that term out front is multiplying by both of the terms inside the bracket. So we'll do 4 times the x, and we will do 4 times the 3. 4 times x is 4x, and 4 times 3 is 12. And it's really important that we don't forget the plus or minus sign that belongs in between these terms. Moving on to more advanced questions like we'll be looking at today, if we have a set of brackets directly in front of another set of brackets, this means that we're going to multiply their contents. So like in example 1 we've got written above, what I really want to do is work out what x plus 3 is, work out what x minus 5 is, and multiply those two answers together. But since I can't perform this calculation, what I need to do is very similar to what I did above. Both of the terms inside the first bracket needs to multiply by both of the terms in the second bracket. So we'll start by setting up the rainbow, as I call it. X multiplies by x, and that makes x squared. The next rainbow, x multiplies by negative 5. So it's going to give me a negative term, that's negative 5x. Remember, the plus or minuses in between terms is really important. Next, we've multiplied x by both terms in the second bracket, so let's go on to the second term in the first bracket. So 3. Now I'm going to do what I call my happy faces. 3 times the first term, 3 times x. That is positive, don't forget the plus sign, 3x. And then I'll do 3 times the minus 5. Now that was a positive 3 times a negative 5. You should know that positive times negative will give you a negative answer, so that's minus 15. Notice that when we expand out brackets, two sets of brackets with 2 terms in each bracket will expand out to be 4 terms. Just as up above, multiplying one term by a bracket with 2 terms in it, 2 terms, expands out to be 2 terms. However, in this case, we can simplify our expression. Do you see the like terms that could be grouped together? Be careful because x squared is not a like term with minus 5x. Like terms have to consist of the exact same variables, but even more important, they must be the same power of the same variables. So x squared is not a like term with an x. However, minus 5x and plus 3x, these are like terms, so they can group together. So let's simplify this expression. X squared will not change, but minus 5x plus 3x will be negative 2x. So we've got x squared minus 2x minus 15. The brackets have been expanded, and that's our simplified answer. You may have seen me talk about expanding brackets when I was writing area expressions in this video. If you're interested in seeing that video, I'm linking it down in the description box for you below as well. But here's an example I did in that video. To work out the expression for the area of this rectangle, where I know that the length is 2 plus x centimeters long, and I know that the width is 3 centimeters. I don't actually know what the length is because I don't know what x is. However, I can write an expression for the area of this rectangle simply by remembering that the area of a rectangle is found by doing length times width. Now, be careful not to overgeneralize. This is not the area for any shape. This only works for rectangles. And if I know that the length is 2 plus x and the width is 3, I would work out the area simply by doing 2 plus x times 3. However, we tend to find this easier when we put the single term in front of the bracket rather than after. So that's the same thing as 3 bracket 2 plus x. So working this through, I'm saying that the area of this rectangle is 3 times 2 centimeters because there are 3 rows of 2 centimeters plus 3 times x centimeters because again there are 3 rows of x centimeters. And of course that expands out to be 3 times 2, which is 6 plus 3x. And you can see that in the area of my rectangle. That is 6 of these centimeter squares plus 3 times a rectangle, which is x centimeters by 1 centimeters. Let's try a more advanced question where we're multiplying 2 sets of brackets together. Remembering that the area of a rectangle is length times width, let's work out the area of this rectangle, where the length is 4 plus x and the width is 2 plus x. First, I'll show you that graphically. So 4 centimeters plus x centimeters. Let me label that for you. So there's my 4 centimeters, and there's my x centimeters. And I'm multiplying that by 2 centimeters, by x centimeters. Okay, and to fill that full rectangle in, this here will be 1 centimeter by x centimeters, and another 1 centimeter by x centimeters, another 1 centimeter by x centimeters, and a fourth 1 centimeter by x centimeters. Now you won't need to draw this diagram to work out the area expression for this rectangle. Let's do this algebraically. Knowing the length and width, this will be 4 plus x times 2 plus x. And since I can't work out what the contents of these brackets are before I multiply, because of course 4 and x are not like terms, they cannot be grouped, what we're going to need to do is multiply both of the terms of the first bracket by both of the terms of the second bracket. Starting with the first term, so I'll do 4 times 2, which is 8. Then again, I'll draw another rainbow here, 4 times x, which is 4x. But don't forget to put the plus or minus between the terms. This is 4 times positive x, that's positive 4x, so plus 4x. I finished multiplying the 4 through by all the terms in the second bracket. So let's go on from our rainbows to our happy faces. So we're going to do x times 2. And again, don't forget the plus or minus. This is positive x times positive 2, so I'll put plus 2x. And then I'll do x times x. And of course, you should know that some value multiplied by itself becomes that value squared, plus x squared. Okay, so I had 2 terms in the first bracket, 2 terms in the second bracket, and when I've expanded that out, I've got 4 terms in total as well. However, notice that we can group like terms to simplify this. We've got 2 like terms here, positive 4x and positive 2x. So let's group them together, that is add them together. 4x plus 2x is 6x. When we rewrite this expression in its simplified form, however, we should generally start with the highest power of the variable and work our way down from there. And if there's more than one variable, we go alphabetical. So this should really be written as x squared plus 6x plus 8. If you left your answer like this, it's still okay. However, when I'm giving answers, I will generally give it in this format. It's practice time, so time for you to go ahead and copy these questions out. Make sure you copy what we're doing here. We are expanding and simplifying. You won't always be told to multiply these brackets out. You should know that when you're asked to expand and simplify and you've got expressions with brackets, that means multiplying them out. In question 2, you are simplifying these index expressions. Remember what an index means, particularly an index of 2. That means you're multiplying the base by itself, so you have 2 of those bases multiplied together. And for question 3, you're going to work out a simplified expression for the areas of these shapes. If you think you know how to get started with that, go ahead and hit pause and do that now. If you feel like you need a bit of a hint, like on question 1C here, which I put a star next to, stick around and I'll give you a bit of a hint about that before you get started. So I'm hoping you can go ahead and do questions 1A and B, no problems. For question C, however, because there are 3 brackets here, what you just need to do is ignore the 3rd bracket at first. We're just going to focus on these 2 brackets. And I'm going to write A plus 3 after my result. So I'm going to expand out these first 2 sets of brackets. So I'll do A times minus 2, 1 times A, and 1 times minus 2, and I'll write my result inside this bracket here. Simplify your expression, and once you've got your 3-term expression, multiply that by the 2nd bracket. So the 1st term times A, the 1st term times 3, the 2nd term times A, the 2nd term times 3, and the 3rd term times A, and the 3rd term times 3. So that should give you a good hint of how you should get started for question 1. If you feel capable, hit pause now and give that a go. If you need a bit of a hint on how to tackle question 2, stick around and I'll tell you how you can do that. So if I just show you how to start question 2A, when you're squaring a bracket, you always need to write the bracket out twice. If you skip out this step, you're most likely going to end up with an expression that doesn't have 4 terms in it. As you know, 2 terms times 2 terms should have. When you multiply these brackets out, however, you'll simplify it down, grouping like terms, and you'll end up with a 3-term expression, which we call a quadratic. That's where you've got a term with an x squared, a term with an x, and a term which is just a number. Quadratics is something that we get into at GCSE, however. For question B, same thing. Write this bracket out, multiplied by that bracket written out again a 2nd time. Same with C. If you think you can do that, go ahead and hit pause and give that a go right now. If you need a bit of a hint about question 3, I'll go ahead and give that to you now. If not, feel free to do it on your own. For question 3A, I shouldn't have to help you with it. You're working out the area of a rectangle here. Area of a rectangle is just A equals length times width. And you're told what the length is and you're told what the width is. Same thing as B. However, C, I hope you noticed, is not a rectangle. C is a triangle. And the area of a triangle is not the same as length times width. In fact, I could redraw this triangle. If I took this half of it and I moved it over here, you would see that that makes a rectangle, where the length is half of x plus 5, and the width is the height of the triangle, which is why the area for a triangle is the base times the height, just like if you were doing the area of a rectangle, but we need to divide it by 2. And for question D, you've noticed this is not a rectangle or a triangle, but you can break it down into parts. You might break it down into 2 rectangles like this. So I would call this top rectangle here rectangle A, and I work out its area. And I call this bottom rectangle here B, and I work out its area. And I'm adding those 2 areas together to get the total area. The difficult bit is working out what the length and width of these rectangles are. But if you found that top rectangle difficult to work out, you could also cut it down this way. You decide how you think it's going to be easier for you to split that into two rectangles. Work out the full area and simplify as much as possible. So I'm going to give you a chance now to hit pause and try that for yourself, and hit play when you're ready to take it up. I hope you had a chance to hit pause, because here come your answers. For question 1, let's multiply these brackets out. So for A, here I've expanded out, and here I've grouped my like terms together and simplified. For question B, I expanded out, and I grouped my like terms to simplify. For question C, as I showed you, first expand the first two brackets, but don't forget to write the third bracket, simplify, and then multiply the two remaining sets of brackets. Notice that there are 3 terms in the first bracket and 2 terms in the second bracket. That's going to give us 6 terms in our result, 3 times 2. But there are some like terms here, so let's group them together. Let's group our a squares together. Let's group our a's together. So we have a cubed plus 2a squared minus 5a minus 6. And notice I listed my terms in descending order of power for my variable. So a to the power of 3, a to the power of 2, a to the power of 1, and our term with no a's at all. On to question 2, remember to write the brackets out 2 times and then expand those brackets. So question A, expanded out and simplified. Question B, expanded out and simplified. And question C, expanded out and simplified. For question 3A should have been fairly straightforward. Bracket times bracket, length times width. First, I'll expand it out, and then I'll group like terms to simplify. For question B as well, length times width, bracket times bracket. First, I'll expand it out, and then I'll group like terms to simplify. Now, I like this answer because I know we see it a lot at higher GCSE. This is something we call dots. And I wonder if anybody knows what dots stands for. Let me know down in the comment section if you can figure it out. For question 3C, remember we could treat a triangle as half of a rectangle. So we've done base, which is x plus 5, times height, which is 4 minus 2x, but don't forget to divide by 2. So x plus 5 times 4 minus 2x over 2. First, we'll expand those brackets out, and don't forget to put it over 2. Then we'll group our like terms. And just as one value multiplied by all terms inside a bracket, a fraction where all terms are over 2 means each of those terms is being divided by 2. So we'll do negative 2x divided by 2. Negative 2 divided by 2 should be negative 1. Negative 6x divided by 2. Negative 6 divided by 2 is negative 3, so negative 3x. And 20 divided by 2, which is 10. So we've got negative x squared minus 3x plus 10. For question D, you may not have split it the way I've split it here. However, for me, I thought this was the easier way. So I split this strange composite shape into 2 rectangles, where I'm going to call the top rectangle A and the bottom rectangle B. And to find out the total area of the shape, I'm going to work out what the area of A is, and I'm going to add that to the area of B. So the area of A, it's a rectangle, so I'll do length times width. I know my length is y minus 2, but my width was x plus 3, but I'm taking away the 4. So I'll write this over here, x plus 3 minus 4. Now that can be simplified, grouping my like terms. 3 minus 4, that's negative 1. So that's x minus 1. And I like to label that on my diagram so that I can clearly see where my values came from. But as you can see, I'm having trouble writing that on the computer. So this is x plus 1. And for my rectangle down below, I know that my length is y plus 8, and I know that my width is 4. So my area is y minus 2 times x minus 1 plus 4 times y plus 8. So let's expand these out. Let's group like terms to simplify. So I've put my x terms first, then I've got my xy terms, then I've got my y terms, and then I've got my number terms. So I'm trying to go alphabetically here. X comes before y. So how did you do? Please let me know down in the comment section if you had any trouble or you think I've made a mistake here, which is also a possibility. Otherwise, well done. Keep up the good work, keep practicing, and I'll see you soon.